The point-slope form of the equation of the line with slope m passing through the point x1, y1 is given by the equation y minus y1 equals m times the quantity x minus x1. Example 1. Write an equation of the line through -4, 1 having slope of -3. First, I want to start by labeling x1, y1 in the equation. Here, x1 is -4, y1 is 1, and the slope is given as -3. We use the point-slope formula. Y minus y1 equals m times the quantity x minus x1. And I'm going to plug in the value of y1, which is 1, into the equation. The slope is -3, so we'll plug in -3 for m. And have x minus a -4. That was x1. We plugged in a -4 into the equation. Now you want to be extra careful with the sign. This double negative is going to become positive. So now we have y minus 1 equals -3 times x plus 4. I'm going to distribute the -3 to the parentheses x plus 4. Y minus 1 equals -3x minus 12 by distribution. We can add the 1 to both sides to give us y equals -3x minus 11. This is our solution to the problem y equals -3x minus 11, the equation of the line that goes through the point -4, 1 and has a slope of -3. Example 2. Write an equation of the line through -3, 2 and 2, -4. Write the results in standard form. Ax plus by equals c. We will start by labeling the points x1, y1 and this point x2, y2. And we'll have to find the slope first. So we'll take -4 minus 2 divided by 2 minus -3. Again, this double negative becomes a plus. So we have the slope is -6 divided by 5. Recall the formula for the slope is m equals y2 minus y1 divided by x2 minus x1. The slope is -6/5. Now we can use either the point -3, 2 or the point 2, -4 for x1, y1. We're going to choose, in this case, -3, 2. We have x1, y1 as -3, 2. And we'll use the same equation as before. Y minus y1 equals m times the quantity x minus x1. I will plug in the value of 2 for y1, the value of -3 for x1, and the slope is -6/5, so we'll plug that in for the m. Y minus 2 is now equal to -6/5 times the quantity x minus a -3. And of course the double negative becomes a plus sign again. So we have y minus 2 equals -6/5 times the quantity x plus 3. I can multiply both sides of the equation by 5 to get rid of the fraction. And that results in 5 times the quantity y minus 2 equals -6 times the quantity x plus 3. Let's distribute the 5 throughout the left side, and we'll distribute the -6 to the right side. That results in 5 times y is 5y, 5 times -2 is -10, -6 times x is -6x, -6 times 3 is 18. We can collect like terms now by adding the 10 to both sides, and adding the 6x to both sides. This gives us 6x plus 5y equals negative 8, which is the standard form that we were looking for. The slope-intercept form of the line with slope m and y-intercept 0b is given as the follows: y equals mx plus b. Remember, the m represents the slope, and the b is going to tell us the y-intercept of our line. Example 3. Find the slope and y-intercept of the line with equation 4x plus 5y equals negative 10. In order to find the slope and y-intercept, I want to rewrite my equation in slope-intercept form, or y equals mx plus b form. So let's start by subtracting the 4x to both sides. You want to make sure the 4x comes before the negative 10, so it looks more like the slope-intercept form. Let's also divide everything by 5. And that reduces to y equals negative 4/5 x minus 2. And the slope is here, the number in front of the x, so m equals negative 4/5. And the b is going to tell me the y-intercept. The y-intercept is 0, negative 2. Example 4. Write an equation of a line through 1, 1, and 2, 4. Then graph using the slope-intercept form. Using the slope-intercept form, first find the slope. So we're going to start by labeling this as x1, y1, x2, y2, and using the formula for slope, which is, again, m equals y2 minus y1 divided by x2 minus x1. Using this formula, we have the slope m is equal to 4 minus 1 divided by 2 minus 1, which equals to 3 over 1, or simply the slope is 3. We can now substitute this slope for the equation y equals mx plus b and choose one of the given points. I'll choose 1, 1 because that's the easiest point to select. So we'll plug in the slope, which we found to be 3, and we'll solve for b using the point 1, 1. Now remember, 1, 1 represents x, y. So we're replacing the y with 1 and the x with the number 1. So we have 1 equals 3 times 1 plus b. And of course 3 times 1 is going to give us 3. And we can subtract that to the other side to get us negative 2. So the y-intercept is negative 2. And we can plug this back into the equation y equals 3x minus 2 because we know the slope is 3 and the y-intercept was negative 2. In order to graph this, we have to plot the point 0, negative 2, and then we'll use this definition slope to arrive at the point 1, 1. So let's graph it. I start by plotting the y-intercept, 0, negative 2, and the slope has a rise of 3, so we'll count 1, 2, 3, and a run of 1. So we do end up at the point 1, 1. I can do it again, a rise of 3, 1, 2, 3, and a run of 1, and we end up at another point, 2, 4, and we can draw a line through those points. Now, if I am given this graph and I want to find the slope, I will start by selecting 2 points that are convenient to use. Here the point is 3, 0 and 0, negative 1. I start with the rise. It looks like we're going to have to rise -1, which means go down 1, and go to the right 3 spaces. So the slope m is equal to -1/3. To find the y-intercept, we want to know where it crosses the y-axis, and the y-intercept is just going to be 0, -1, because that's where it crosses the y-intercept. The x-intercept is the point where it crosses the x-axis, so the x-intercept is -3, 0, and the y-intercept is 0, -1. Write the equation that defines f. I know the slope m is -1/3. And I know the y-intercept is a -1. So using the formula y equals mx plus b, we can find the equation of the line as f of x equals -1/3 x minus 1. Here, instead of y, we're using f of x, or function notation. An equation of the vertical line through the point a comma b is x equals a, because x represents the x coordinate. An equation of a horizontal line through the point a comma b is the equation y equals b. So remember, x represents a vertical line, x equal to some number represents a vertical line, and a horizontal line is represented by y equal to some number b, which corresponds to the y coordinate. Definition of a parallel line is two distinct non-vertical lines that are parallel if and only if they have the same slope. So if they have the same slope, these two lines will never intersect. Perpendicular lines are two lines neither of which is vertical, are perpendicular if and only if their slopes have a product of -1. Thus, the slopes of perpendicular lines, neither of which are vertical, are negative reciprocals. Essentially, if the slope of the first line is a over b, then the slope of the second line, in order to be perpendicular, must be negative b over a, the negative reciprocal of the other one. Example 6. Write the equation in both slope-intercept form and standard form that passes through the point 3, 5 and satisfies the given condition. We want our line to be parallel to the line 2x plus 5y equals to 4. The point 3, 5 is on the line, so we need only to find the slope to use the point-slope form. We find the slope by writing the equation of the given line in slope-intercept form, that is, we want to solve for y first. So we'll solve for y by subtracting the 2x to both sides. And that gives us 5y equals -2x plus 4. Let's divide both sides by 5. And that simplifies to y equals -2/5 x plus 4/5. Now we only want to look at the slope. Since the slope is -2/5, I want my slope to be parallel to that, so we're going to use the same slope. The slope is -2/5. Since the lines are parallel, -2/5 is also the slope of the line whose equation is to be found. Point slope formula, y minus y1 equals m times the quantity x minus x1. x1 is 3 and y1 is going to be 5, and our slope was the slope we found earlier. Y minus 5 equals -2/5, which was the slope we found earlier, times the quantity x minus 3. We're going to distribute the -2/5 throughout the equation. So y minus 5 equals negative 2/5 x plus 6/5, because 2 times 3 gives us the 6. And the fraction had a denominator of 5, so it gives us 6/5. And this is our equation of our line. We can go a step further by simplifying it. If we wanted to, you would just have to add the 5 to both sides. If I add the 5 to both sides, I have y equals negative 2/5 x plus 31 over 5. And this is our solution of a line that is parallel to the equation 2x plus 5y equals 4 and goes through the point 3, 5. In order to write this in standard form, I can multiply everything by 5, and that reduces to 5y equals negative 2x plus 31. Adding the 2x to both sides, we have the standard form 2x plus 5y equals 31. Example 6. Write the equation in both slope-intercept form and standard form of the line that passes through the point 3, 5 and satisfies the given condition. This time I want a perpendicular line to the equation 2x plus 5y equals 4. So we'll start by realizing the slope from part A was negative 2/5. So we'll use that same slope again. The slope was negative 2/5. But I want a line that's perpendicular to this line, so we'll take the negative reciprocal. We'll use 5 over 2 instead of negative 2/5. These two have to be opposite signs and reciprocals of each other. So that's the slope we'll use. We'll use the slope 5 over 2. Again, we'll use the equation for the point slope form. Y minus y1 equals m times the quantity x minus x1. M, remember, is 5 over 2. And x1, y1 is 3, 5. Y minus 5 equals 5 over 2 times the quantity x minus 3. We will distribute the 5 over 2 to the right side of the parentheses. After we distribute, we get y minus 5 equals 5 over 2x minus 15 over 2. And we can simplify this by adding the 5 to both sides of the equation. And that reduces to y equals 5 over 2x minus 5 over 2. I can now multiply everything by 2 to get rid of the fractions. So now we have 2y equals 5x minus 5. In order to set this in standard form, I can subtract the 2y to both sides and add 5 to both sides, and that simplifies our equation to 5x minus 2y equals 5. And this is what we call standard form, that ax plus by equal to some number c. The slope-intercept form is the form y equals 5 over 2x minus 5 halves. Let's review. Y equals mx plus b is the slope-intercept form, where m is the slope and b represents the y-intercept. The point slope form is y minus y1 equals m times the quantity x minus x1. So when do you use this equation versus this equation? The first equation is used mainly for graphing. It allows you to quickly plot the y-intercept and the slope, and you'll be able to graph a line very easily. The second equation, the point slope form, is used when you want to find an equation of a line and you're given a slope and a point. Y equal to B is a horizontal line. It has a y-intercept of 0b with a slope of 0. X equals A represents a vertical line and the slope is undefined. Recall, all vertical lines have undefined slope, and in this case the x-intercept for a vertical line is A, 0. Example 7. Average annual tuition and fees for an in-state student at public four-year colleges are shown in the table for the selected years and graphed as ordered pairs of the points where x equals 0 corresponds to 2009 and x equals 1 corresponds to 2010, and so on. And y represents the cost in dollars. This graph of ordered pairs of the data is called a scatter diagram. So we have a scatter diagram. It shows us in 2009 we have $6,312 for tuition. In 2010 we have $6,695 for tuition, and it appears to have an increase over time for the 4 years. Find an equation that models the data. The points lie approximately on a straight line. Write a linear equation that models the relationship between the year x and the cost y. Choose the data points 0, 6,312 and 4, 8,070 to find the slope of the line. We use the equation for the slope formula. M equals y2 minus y1 divided by x2 minus x1. So 8,070 minus 6,312 divided by 4 minus 0 gives us 1,758 divided by 4, or 439.50. The slope 439.5 indicates that the cost of tuition and fees increased by about $440 per year. Use this slope, the y-intercept 0, 6,312, and the slope-intercept form to write the equation of the line. Recall, y equals mx plus b is the slope-intercept form. We'll plug in the slope, which we found earlier to be $439.50, x plus the y-intercept 6,312, and this is our equation that models the rise of tuition. B. Use the equation from Part A to predict the cost of tuition and fees at public four-year colleges in 2015. We know that x equals 6 corresponds to the year 2015, so we want to substitute 6 for x. Plugging in x equals 6 from part A into our equation, we have y equals 439.5 times 6 plus 6,312. Use a calculator to simplify this number, and y equals 8,949. The model predicts that the average tuition and fees for in-state students at public four-year colleges in 2015 would be about $8,949.